This screencast is going to talk you through how to do this a little bit more complex, a little more sophisticated sequence of rocks, intrusions, faulting, and just applying the concept of relative age dating, and I've got unconformity. So first thing I did was I went through and found all the dark lines, and I labeled, here's an unconformity, 2, here's an unconformity, 3, here's an unconformity, and here's a 4th unconformity. So I have 4 of these, so I'll come back to those. You need to make sure you pay attention to what's going on. Relative age relationships in geologic cross-section. B and C are both igneous, so B and C are igneous. M, this layer here, is metamorphic, deformed metamorphic rock. And F and Z are fault, so F and Z. And then all others are sedimentary rocks or sediment. So we'll talk J would be sediment. So let's jump in here. So I'm just going to get into my numbering system. But I'm first going to number them off over in the margins, just to make sure we have a chance to talk through them before I label them here. So if I look here, I know that M has to be the oldest sequence. M has to be. Here's why. These faults tell me that. Well, I know that the fault here, that the fault F cut through several layers, several sequences here. But here I know that Z, in this case, also cut through. So I've got some evidences here that tells me that, okay, well, M had to have existed prior. And I'll see that C grew into this, and it went up to the fault. So it has to be younger than this particular sequence as well. So I've got M to start this off. M is the oldest. Above it, I've got sedimentary layers G, A, and K. I can't ignore what's going on over here. So G, A, and K. So M, G, A, K. And in this case, I also have, let's see, K, and then I have a sequence that shifted them. Here we go. My cross-cutting relationship is going to be letter Z. Now, letter Z here is a fault. In this case, this sequence was either pushed up or this layer was pushed down. So notice, this layer here is an extension of K. So I've got this all the way up to Z. My next layer next sequence I can see here is letter C. And letter C had to have existed because here I see the intrusion, let's just say growing into this igneous rock body, grew into where this fault is, but it did not disrupt this sequence here, or this fault here is going to later distract it. So we're going to say that letter C has to be next, before letter F. So I have these faults that tell me that this fault occurred, then my igneous body occurred, and then this fault then cut it. And I know this all because the faulting occurred at the point of the unconformity. This unconformity here tells me that these faulting had to have taken place after these circumstances took place. So using geologic thinking, I continue moving on here. Above letter F, or above fault F, I've got letter D. Above letter D, I have letter N. Then I have letter B, disregard the bell. I've got letter B, this is an igneous intrusion here. B, igneous intrusion. This one actually would technically, because it cut through, but because it grew laterally, this one here would be a sill. And we haven't talked a whole lot about sills, but something that cuts through, cross-cuts an igneous body here, this here is called a dike that cross-cuts through sedimentary layers. But if it expands and grows out parallel to the sedimentary rock layers, we call that a sill. So adding a new terminology piece here. And so after I look at letter B, this igneous body, then I can go ahead and finish up my sequence. So this should be easy to use. So L, T, R, J. So I'll label those L, T, R, and J. So if I go back and look at these, so I can sequence this. I can say that M, G, A, K, Z, C, F, D, N, B, L, T, R, J. So M, G, A, K, Z, C, F, D, N, B, L, T, R, J. That's proper. That's the proper sequence. So now it says, make sure you look at the sequences. What are taking place with these unconformities? Well, number one is cutting through, this is sedimentary rock on top of metamorphic. So I know that this here, number one, is a non-conformity. Right? These are all different types of unconformities. They do not conform to what was taking place prior, based on this erosional layer. So number two, this here would be an angular unconformity. I have sedimentary rock on top of tilted sedimentary rock. So that defines it, number two, as an angular unconformity. Number 3. I want to look at number 3 here for a second because I've got a couple features going on. L to N, this would be a disconformity. So I've actually got 2. Ln would be a disconformity, whereas L to B would be a nonconformity, right? Sedimentary over igneous is a nonconformity, whereas L to N is a disconformity. And then lastly, number 4 up here, and J is likely sediment. It's still being deposited or eroded here, but I haven't determined if it's rock or sediment. It says it right here. Is it rock or is it sediment? It doesn't really matter in this case, but number 4 would be an angular unconformity. So we have this sequence of circumstances that took place that tells me that this rock sequence is very much what happened, and these are the unconformities that we see taking place here. I hope that helps.